Hello everyone, welcome to my YouTube channel. So today we are going to discuss about robotic arms for prosthetics. So far we had discussed about how exactly our particular human organs are working. So we started with the brain. We discussed about how brain works as CPU, and then we discussed about the architecture of the brain, how exactly the architecture of the brain looks like, and we compared with it CPU, right? Then also we discussed about the signal processing, how exactly the signal processing is happening inside the brain. Okay, so with this, and also we discussed about one more topic. So today we are going to discuss about our robotic arms for prosthetics. So, what do you mean by prosthetics? Those who are from biological background will be knowing what is prosthetics. But others, you might have seen some of the people who are not having access to the particular sport devices. They will usually go for example, some of the in some of the sports you might have witnessed that the person who is not having the leg is going is having artificial leg, or you can call it as a prosthetic understanding. So that means it is made up of, that leg is made up of some metal. Okay, some metal in the sense it can be the, most of the times it will be the titanium or any other materials it will be used to make us like a shape of the leg. Okay, so even you might have witnessed this thing for even robotic arms and all, right? For arms, those who are not having arms or legs, usually we go for prosthetics. We use it as artificial legs or hands, most widely used in these two particular applications. So specifically, if you want to see what is prosthetic, it's nothing but something which is artificial to replace the actual thing. It can be the leg or hand or any other part of the body. Okay, so now I hope you understood what is prosthetics. ಸೊ ಪ್ರೊಸ್ಥೆಟಿಕ್ಸ್ ಅಂದರೆ ಏನಪ್ಪ ಅಂದರೆ, ಏನಾದರೂ ಎಕ್ಸ್ಟ್ರಾ ಪಾರ್ಟ್ ನಮ್ಮ ಆರ್ಟಿಫಿಷಿಯಲ್ ಆಗಿ ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು ಬಾಡಿ ಪಾರ್ಟ್ ಇಲ್ಲದೆ ಹೋದಾಗ ಅಥವಾ ಆಕ್ಸಿಡೆಂಟಲ್ಲಿ ಅದನ್ನು ಕಳ್ಕೊಂಡಾಗ ನಾವು ಅದನ್ನು ಫಿಕ್ಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಒಂದು ಆರ್ಟಿಫಿಷಿಯಲ್ ಇದನ್ನು, ಸೊ ಅದನ್ನು ನಾವು ಪ್ರೊಸ್ಥೆಟಿಕ್ ಅಂತ ಕರಿತೀವಿ. So what are the speciality of this particular prosthetics? Prosthetic should adapt to the particular human being, or it should not have any adverse effects on the human being. It should be biocompatible, so that particular whenever there is an amputation, or whenever there is, because of the accident or whatever it is, if the leg has to be removed, or if the hand has to be removed in particular diseases, so then we need to use prosthetics, so that the particular movement should be there. As if my brain if imagine I am having a prosthetics, then if my brain asks me to run, then it should be able to adjust to that particular thing. All the signals should be received to that particular by the prosthetic device, and it should start functioning as a normal leg. So that's why we are calling it as a prosthetics. Understood? So now in this topic we are going to discuss about robotic arms for prosthetics. So let's start. So robotic arms for prosthetics are advanced prosthetic devices. Okay, so they are not just a normal device what we use it for normal engineering applications, but here they usually will have very advanced prosthetic devices. That means they are made up of highly engineered technology is involved, and highly engineered materials are involved. Okay, so that's why it is called it as a, it has been used for prosthetics are nothing but advanced prosthetic devices that use robotic technology. So when you are talking about the robotic arms, it has to use the advanced prosthetic devices, because it should act like a particular robot itself. So that use a robotic technology to restore the functionality. That means to restore the function of the arm here. That means it should act as a normal arm of a human being. So to restore the functionality of the functionality to individuals, that means the patients with upper limb amputation, that means upper limb amputation, because you are talking about the arms. So understood? So robotic arms for the prosthetics are nothing but advanced prosthetic devices that use the robotic technology. Obviously, since it is a robotic arm, it has to use the robotic technology. For what purpose? To restore the functionality of to the individuals with upper limb amputation. Where amputations are nothing but what? When the particular part of the body is cut. For example, here in this case, arm has been cut. So your upper limb amputation. So that's how we can use. So these devices typically use motors, actuators and sensors. This is not just one material. It's a composition of all different materials. The motors are involved for the movement purposes, for direction purposes, and actuators are involved because whenever there is a signal has been given, the movement should be there. For that we need actuators and sensors. Sensors obviously to sense the particular thing, right? If you want to hold something, then your brain should receive the signal that the arm is holding, right? Even if you are with your open eyes you can say, but with your closed eyes, if you want to sense a particular thing, you should have sensors in that particular prosthetics. So these are composed of what? Motors, actuators and sensors. These are the major three components of this particular devices. Okay, so why we need all these motors, actuators and sensors? To mimic the movement of the human arm and hand. Why? Because our arm or a hand, it works, it has got particular motors in the sense here whatever the devices and the muscles will act as a motors, whereas actuators will, again the muscles will act as actuation, will be there, contraction and relaxation. Okay, so that was done by the actuators. And our skin, so that skin is taking up the particular this thing, whatever sensing. So that's why we need sensors to mimic the movement of the human arm and hand. So allowing the wearer to perform the tasks such as reaching, grasping and manipulating the objects. You can reach and grasp a particular thing, you can hold particular thing and you can manipulate the objects. So here these are the functions of the robotic arms, which should act as a normal arm, that is the reaching, grasping and manipulating the objects. So I hope you understood. So I'll just explain briefly in Kannada language. So robotic arms ಅಂದ್ರೆ ಏನಪ್ಪ ಅಂದರೆ ಇದು ಪ್ರೊಸ್ಥೆಟಿಕ್ಸ್ ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ನಲ್ಲ, ಆ ಪ್ರೊಸ್ಥೆಟಿಕ್ಸೇ ಯೂಸ್ ಆಗಿರುತ್ತೆ ಇದರಲ್ಲಿ robotic arms ಅಲ್ಲಿ. ಬಟ್ ಇದು robotic arms ಅಲ್ಲಿ ಅಡ್ವಾನ್ಸ್ಡ್ ಪ್ರೊಸ್ಥೆಟಿಕ್ ಡಿವೈಸಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿರ್ತೇವೆ. ಯಾವುದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಟು ರಿಸ್ಟೋರ್ ದಿ ಫಂಕ್ಷನಾಲಿಟಿ ಆಫ್ ಇಂಡಿವಿಜುವಲ್. ಯಾಕೆ ಅಂದರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮಗೆ ಹ್ಯಾಂಡ್ ಇಲ್ಲ ಅಂದರೆ ಅದರದ್ದು ಫಂಕ್ಷನ್, ಹ್ಯಾಂಡ್ ಇದ್ ಫಂಕ್ಷನ್ ಏನು, ಅದನ್ನು ಲೆಗ್ ಇಲ್ಲ ಅಂದರೆ ಲೆಗ್ಗಿನ ಫಂಕ್ಷನ್ ಅದೇನು ಕೆಲಸ ಮಾಡುತ್ತೆ ಅದು ಸಹ ಅದೇ ಥರ ಕೆಲಸ ಮಾಡಬೇಕು. ಆ ಕೆಲಸವನ್ನು ನಾವು ವಾಪಸ್ ಪಡೆಯಲಿಕ್ಕೋಸ್ಕರ ನಾವು ಇದನ್ನು ರೋಬೋಟಿಕ್ ಆರ್ಮನ್ನು ಯೂಸ್ ಮಾಡ್ತಿದ್ದೇವೆ. ಸೊ ರೋಬೋಟಿಕ್ ಆರ್ಮಲ್ಲಿ 3 ವಿಧಗಳಿರುತ್ತೆ, ಅಂದರೆ 3 ಕಾಂಪೊನೆಂಟ್ಗಳಿರುತ್ತೆ. ಯಾವುದೆಲ್ಲ ಅಂದರೆ ಮೋಟಾರ್ಸ್, ಆಕ್ಚುವೇಟರ್ಸ್, ಸೆನ್ಸರ್ಸ್. ಮೋಟಾರ್ಸ್ ಏನಕ್ಕೆಪ್ಪ ಅಂದರೆ ಮೂಮೆಂಟಿಗೆ, ಡೈರೆಕ್ಷನ್ ಚೇಂಜು ಅದು ಇದಕ್ಕೆಲ್ಲ. ಆಕ್ಚುವೇಟರ್ಸ್ ಅಂದರೆ ಹೋಲ್ಡಿಂಗು, ರಿಲ್ಯಾಕ್ಸೇಷನು ಅದಕ್ಕೆಲ್ಲ ನಾವು ಮಾಡ್ತೀವಲ್ಲ, ಹ್ಯಾಂಡ್ ಎಲ್ಲ ಮಾಡುತ್ತಲ್ಲ, ರಿಲ್ಯಾಕ್ಸೇಷನ್, ಕಾಂಟ್ರಾಕ್ಷನ್ ಅದೆಲ್ಲ ಆಗಬೇಕು, ಲೈಕ್ ಮಸಲ್ ಥರ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ಸೆನ್ಸರ್ಸ್ ಇರಬೇಕು, ಯಾಕಂದರೆ ನಮ್ಮ ಸ್ಕಿನ್ ಹೇಗೆ ನಮ್ಮ ಸೆನ್ಸ್ ಮಾಡುತ್ತೆ ಏನಾದರೂ ಟಚ್ ಮಾಡಿದ ತಕ್ಷಣ, ಸೊ ಆ ಥರ ಸೆನ್ಸರ್ಸ್ ಇರಬೇಕು ಈ ಹ್ಯಾಂಡಲ್ಲಿ ಸಹ. ಸೊ ಈ 3 ಇರಬೇಕು. ಯಾವುದಕ್ಕೆ ಅಂದರೆ ಮಿಮಿಕ್ ಮಾಡೋಕ್ಕೆ, ಕಾಪಿ ಮಾಡೋಕ್ಕೆ, ಏನನ್ನ ಮೂಮೆಂಟ್ ಆಫ್ ದಿ ಹ್ಯಾಂಡ್, ಹ್ಯೂಮನ್ ಹ್ಯಾಂಡ್ ಆರ್ ಹ್ಯೂಮನ್ ಆರ್ಮ್. ಸೊ ಇದರಿಂದ ಇದು ಅಚೀವ್ ಮಾಡೋದ್ರಿಂದ ನಾವೇನನ್ನ ಇದು ಮಾಡ್ಬೋದು, ಯಾವುದೆಲ್ಲ ಫಂಕ್ಷನ್ಸನ್ನು ಮಾಡ್ಬೋದು ಅಂದರೆ ರೀಚಿಂಗ್. ನಾವು ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಏನಾದರೂ ಹಿಡ್ಕೋಬೇಕು ಅಂದರೆ ಅಲ್ಲಿವರೆಗೂ ನಾವು ಮೂಮೆಂಟನ್ನು ರೀಚ್ ಮಾಡಬೇಕು, ನಮ್ಮ ಹ್ಯಾಂಡನ್ನು ರೀಚ್ ಮಾಡಬೇಕು, ಅದಕ್ಕೆ ಬೇಕಾಗತ್ತೆ. ಮತ್ತು ಗ್ರಾಸ್ಪಿಂಗ್, ಏನಾದರೂ ಹೋಲ್ಡ್ ಮಾಡಬೇಕಾದ್ರೆ. ಸೊ ಆಮೇಲೆ ಮ್ಯಾನಿಪುಲೇಟಿಂಗ್ ಆಬ್ಜೆಕ್ಟ್ಸ್, ಅಥವಾ ನಾವು ಏನಾದರೂ ಈ ಆಬ್ಜೆಕ್ಟನ್ನು ತೆಗೆದು ಈ ಫೋನನ್ನು ತೆಗೆದು ಆ ಕಡೆ ಇಡೋಕ್ಕೆ, ಅಥವಾ ಅಲ್ಲಿಂದ ತೆಗೆದು ಈ ಕಡೆ ಇಡೋಕ್ಕೆ, ಆ ಥರ ನಾರ್ಮಲ್ ಹ್ಯಾಂಡಿನ ಕೆಲಸ ಏನಿದೆ ಅದನ್ನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಷ್ಟೇ. Next, robotic arms for prosthetics can be controlled in a variety of ways. So how it can be controlled? So majorly I am going to explain in 2 ways here. One is direct control through muscle signals, that is you can call it as a myoelectric control, where we are directly controlling by using the muscle signals. So that's why it is called, since it is muscle is involved, myoelectric control. Next we are having brain machine interface, so where the electrodes will be kept implanted in the brain are placed on the scarf here, okay, like EEG, what we discussed in the previous topic, to detect and interpret the brain activity. So whatever the brain is telling, the machine has to do, that is the robot has to do. That's why we need brain machine interface. Okay, so some prosthetic arms also incorporate machine learning algorithms. Nowadays the AI ML is coming in, so machine learning algorithms plays a very important role in this particular research, okay, to improve their performance and adapt to the user's needs over time. So first thing we will discuss, that is what? Direct control through muscle signals, also called as myoelectric control. Why it is myo? Because muscles are involved. So myoelectric control of the robotic arm prosthetic involves using electrical signals generated by the wearer's remaining muscles to control the movement of the prosthetic. So imagine the particular person's hand is cut. Now half of these muscles are still there. So now these muscles has to work, right? They are still functional. They are not completely gone. They are still functional. We are taking the help of these remaining muscles to control the movement of the prosthetic. Understanding? ಇಲ್ಲಿ ನಮ್ಮದು ಹ್ಯಾಂಡ್ ಏನಾದರೂ ಕಟ್ ಆಗಿದೆ ಅಂದರೆ ಒಬ್ಬ ಪರ್ಸನ್ ಇದು, ಆ ಹ್ಯಾಂಡಿದ್ದು ಎಲ್ಲ ಮಸಲ್ಗಳು ಹಾಳಾಗಿರಲ್ಲ, ಆ ಉಳಿದಿರೋ ಮಸಲ್ಗಳು ಫಂಕ್ಷನ್ ಇರುತ್ತೆ. ಆ ಫಂಕ್ಷನನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಈ ಪ್ರೊಸ್ಥೆಟಿಕನ್ನು ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ಬೋದು. ಅದಕ್ಕೆ ನಾವು ಡೈರೆಕ್ಟ್ control through muscle signal. That's why we are calling it as a direct control through muscle signal, because the remaining muscles, with their help, we are connecting it to the prosthetic, so that the movement with the muscles will directly shift to the prosthetic. Okay, so there in that brain machine interface is not required. So that's why it is called as direct control through muscle signals. So muscle is already getting the signal from the brain, and you are just attaching the particular prosthetic, so the movement will be there accordingly. So the system typically involves electrodes, which is placed on the skin over a remaining muscle, that are used to detect and interpret the electrical signal generated by the muscle contraction. So here, since it is based on the muscle, so whatever the electrodes are there, no need to put on brain, because there is no brain machine interface is required. So whatever the electrodes are there, that will be kept on just over a skin. For imagine half of the person's hand has been cut or amputated, so that half of this thing there you can keep this particular electrode, so that the electrodes will sense the signals which is generated by the muscles. Understanding? Or which is taken from the brain to the muscles. Now the muscles movement is there. Based on the muscle movement, the particular remaining muscle movement is then particular the prosthetic will work or move based on the muscle contractions. So this is exactly how it looks like. So you have actuators here, okay, you have a remaining muscle here, so that when there is a signal from the muscle, that means this muscle contracts, so the actuator movement will be there. Because of this movement, this control signal will be there, computer interface will be there, EMG will be there, so that the movement of the particular leg will be done. So that this leg, only this half, this particular leg is amputated, imagine like that. So now whatever the movement is there here, this movement will be sensed by the actuator, and the leg will move like that. Feet will move accordingly. Understanding? So imagine this is a leg, this is a feet is amputated. So here is where we are introducing the robotic the particular device, so that the particular movement in this particular skin till here, the electrode will be kept, so that movement will take you for the other movement. That's why it is called as direct, because it is directly we are taking from the muscle. Myoelectric electric, that means we are taking the signal from the myo, that is tissue. Okay, so that's why we are going from that movement. That's why it is called as myoelectric control of an ankle exoskeleton. Example. Okay, understood? That's how about that's what about direct this thing. ಇಲ್ಲಿ ಏನಪ್ಪ ಆಗುತ್ತೆ ಅಂದರೆ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ನಾವು ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ, ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ, ಆಲ್ರೆಡಿ ಕಟ್ ಆಗಿರುತ್ತಲ್ಲ, ಅಲ್ಲಿ ಮಸಲ್ಸ್ಗಳು ಆಕ್ಟಿವ್ ಇರುತ್ತಲ್ಲ, ಅದು ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಅಲ್ಲಿವರೆಗೂ ಬ್ರೈನಿಗೆ ಸಿಗ್ನಲ್ ಬರ್ತಾ ಇರುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ನಾವು ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅನ್ನ ಹಾಕ್ತೀವಿ, ಆ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅಲ್ಲಿ ಸಿಗ್ನಲ್ ಅನ್ನ ತಗೊಂಡು, ಸೊ ಈ ತರ ಇಲ್ಲಿರುತ್ತಲ್ಲ, ಸೊ ಇದು ಇಲ್ಲಿರುವ ಯಾವ್ದೆಲ್ಲ ಎಕ್ಸ್ಟ್ರಾ ಹಾಕಿರ್ತೀವಲ್ಲ, ಆ ಆಂಪ್ಯುಟೇಟೆಡ್ ಪಾರ್ಟ್ ಆಗಿ ಅದು ಕೊಡುತ್ತೆ, ಆ ಸಿಗ್ನಲ್ ಅನ್ನ ರಿಸೀವ್ ಮಾಡ್ಕೊಂಡು ಅದೇ ತರ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಯಾವ ತರ ಮೂವ್ಮೆಂಟ್ ಬೇಕು ಆ ತರ ಬ್ರೈನ್ ಸಿಗ್ನಲ್ ಕೊಟ್ಟಿರುತ್ತೆ, ಅದೇ ತರ ಮೂವ್ಮೆಂಟ್ ಇಲ್ಲಿ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಮಯೋಎಲೆಕ್ಟ್ರಿಕ್ ಮಸಲ್ ಸಿಗ್ನಲ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. Okay, na? That was next. That's it. Next, robotic arms prosthetic by brain machine interface. Here there has to be brain machine interface. That is nothing but you can call it as a BMI. So BMI is nothing but brain machine interfaces. So there are so these particular interfaces are a type of a technology that allows a use of to control a robotic arm prosthetic directly with their brain activity. So you are using the brain activity to control robotic directly. Understanding, there is no muscle movement is involved. You are directly taking the brain's activity, you are recording the brain activity, and based on that the robotic arm is working. For example, in my brain, if I think that I want to hold this phone, so this particular arm should be able to hold that phone. Understanding, that is why it is called as brain machine interface. So the system typically involves electrodes placed on the scalp or implanted directly into the brain to detect and interpret the user's brain signal. So based on the brain's interpretation, the signal transaction study what we did yesterday, so with the help of that, so we are just introducing the electrodes on the scalp of the brain, or you can just directly you can implant inside the brain, so that based on the brain activity, whatever brain tells us to do, the robotic arm should do. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಇದರಲ್ಲಿ ರೋಬೋಟಿಕ್ ಆರ್ಮ್ಸ್ ಅಂದರೆ ಬ್ರೈನ್ ಮಷಿನ್ ಇಂಟರ್ಫೇಸ್ ಅಂತ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಮಸಲ್ ಇದೆ, ಯಾವುದೇ ಇನ್ವಾಲ್ವ್ಮೆಂಟ್ ಇರಲ್ಲ. ನಮ್ಮ ತಲೆಯಲ್ಲಿ ಏನು ಯೋಚನೆ ಬರುತ್ತೆ ಅದೇ ಥರ ಮೂವ್ಮೆಂಟ್ ಆಗಬೇಕು ಹ್ಯಾಂಡ್ ಇದು. ಸೊ ಅದಾಗಬೇಕಂದ್ರೆ ಏನು ಬೇಕು? ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಬೇಕಾಗುತ್ತೆ. ಅದನ್ನು ಎಲ್ಲಿಡಬೇಕು? ಬ್ರೈನ್ಸ್ ಆಕ್ಟಿವಿಟಿ ಹೇಗೆ ಮೆಜರ್ ಮಾಡ್ತೀವಲ್ಲ ಈ ಏಜಿಯಲ್ಲಿ ಅದೇ ಥರ ಇಡಬೇಕು, ಅಥವಾ ಬ್ರೈನ್ ಒಳಗಡೆ ಸಹ ನಾವು ಇಂಪ್ಲಾಂಟ್ ಮಾಡ್ಬೋದು. ಅದರಿಂದ ನಾವು ಬ್ರೈನ್ ಇದು ಏನು ಸಿಗ್ನಲ್ ಇದೆ ಅದನ್ನು ಡಿಟೆಕ್ಟ್ ಮಾಡಿ ಇಂಟರ್ಪ್ರೆಟ್ ಮಾಡಿ ಅದೇ ಥರ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ರೋಬೋಟಿಕ್ ಆರ್ಮ್ ವರ್ಕ್ ಆಗುತ್ತೆ. Okay, so this is how it looks like. We have got the brain's activity, signal acquisition will be there from the brain, from the electrodes, that is digitalized signal will be converted, and then signal processing will be there, feature extraction, translation and all. So based on the after the translation, command will be given to the particular your robotic arm, so that the robotic arm can able to hold this. Okay, representation of brain machine interface. Okay. So that's it. If any doubts are there, please let me know. Next topic we are having engineering solutions for Parkinson disease, that we will discuss in the next class.